Welcome to The Explainer. Look, if you're a developer, an engineer, or really anyone working closely with AI and large language models right now, you definitely know the daily headache of trying to extract accurate information from long, complex documents. You load up a dense PDF, run it through your traditional retrieval augmented generation pipeline, RAG for short, and basically just cross your fingers. But instead of getting the exact paragraph you needed, the AI hallucinates. Or worse, it pulls completely irrelevant text just because a couple of keywords happen to match. It is incredibly frustrating. Well, today, we're looking at a fundamentally different approach that completely rips up the old playbook.
Okay, let's dive into this. Are you frustrated with vector database retrieval accuracy? Because the reality is, traditional vector databases essentially take your beautifully structured, highly professional documents and throw them straight into a blender. They chop the text into these arbitrary little chunks, convert those chunks into mathematical vectors, and then do a totally blind search based on proximity. It's what a lot of folks in the field jokingly call vibe retrieval. The system finds something that mathematically feels kind of similar to your query, but similarity is absolutely not what you're actually looking for when you're querying a highly technical file, right?
And that brings us to the core thesis of today's explainer. Similarity fundamentally does not equal relevance. When you're dealing with professional documents, think massive legal contracts, dense academic papers, or complex financial reports, getting the right answer demands multi-step reasoning. You need a system that actually understands the context of the entire document, not just some system that matches the keyword revenue to a random paragraph from page 42 just because they share a semantic vector space. True relevance requires real reasoning.
To break down exactly how we fix this, here's our roadmap for today. First, the vector RAG problem. Second, similarity versus relevance. Third, enter reasoning-based RAG. Fourth, how PageIndex works. Fifth, the FinanceBench test. And finally, number 6, deploying PageIndex.
All right, part 1, the vector RAG problem. Let's look at the limits of similarity search in complex documents.
When we're dealing with complex documents that demand real domain expertise, traditional methods completely break down. Traditional vector RAG is fundamentally flawed because it operates on a huge assumption that just because two pieces of text look mathematically similar, they must contain the correct answer. But imagine asking an AI about the risk factors in a company's Q3 earnings report. A traditional vector system might easily pull a chunk of text from Q1 just because it uses the exact same phrasing. It has literally no concept of the document's actual structure or the logical progression of the information. It lacks domain expertise entirely.
Moving to part 2, similarity is not relevant. Let's contrast the old way with the new paradigm.
And this brilliantly illustrates exactly what we're talking about. If the old way is broken, what's the alternative? Well, we have the old guard, traditional vector RAG. It relies heavily on artificial chunking. Think about how wild that is for a second. Taking a carefully authored financial report and arbitrarily slicing it up every 500 tokens, completely destroying the author's intended context. It results in this opaque vibe retrieval, where you can't really explain why the AI pulled that specific text. But as an alternative, we have a new framework called PageIndex. PageIndex achieves relevance through actual reasoning. It keeps your documents in their natural intended sections, and crucially, it is entirely traceable and explainable. You know exactly why it found what it found.
Which brings us to section 3. Enter reasoning-based RAG. Agent context-aware document retrieval.
This is an agentic, context-aware approach that is literally the ultimate antidote to the problems we just talked about. I absolutely love this quote from the developers at Vectify AI. Inspired by AlphaGo, we propose PageIndex, a vectorless, reasoning-based RAG system. It simulates how human experts navigate and extract knowledge from complex documents through tree search. Think about how a human expert reads a 200-page textbook. They don't scan every single word looking for a keyword like a robot. They look at the table of contents, they find the relevant chapter, they logically navigate down to the specific subheading, and then they read the paragraph. PageIndex gives large language models the ability to do exactly that. It's logical, hierarchical navigation.
Let's rapid fire through the core features you get when you adopt this architecture, because they're a huge deal. First, and perhaps most shockingly, no vector database required. None. You can ditch it entirely. Second, no artificial text chunking. Your documents stay intact, logically grouped the way they were written. Third, you get human-like agentic retrieval, where the AI actually thinks about where it needs to look. And finally, you get way better explainability. Because it's navigating actual document structures, it can give you exact page and section references. We're getting rid of the opaque math completely.
Section 4. How PageIndex works. Let's build that tree structure.
So, the crucial point is, how exactly does it pull this off without a vector database? Well, the underlying logic is a surprisingly elegant two-step architecture. Step 1, PageIndex processes your PDF or document and generates a highly semantic table of contents tree structure. It maps out all the headings, subheadings, and sections. Step 2, when you ask a question, it uses an LLM to perform reasoning-based retrieval through a tree search. The LLM literally looks at the tree and thinks to itself, okay, the user is asking about Q4 revenue, so I need to go down the financials branch, then the quarterly results branch, and it navigates directly to the correct section. Because of this specific tree search methodology, PageIndex is an absolute game changer for lengthy, dense files, where standard context limits normally just ruin AI performance. We're talking about massive financial reports, dense SEC filings, thick regulatory filings, academic textbooks, and complex legal or technical manuals. Basically, if your document is incredibly long and highly structured, this is exactly the system you want to be using.
Section 5, the FinanceBench accuracy test. Let's validate this vectorless reasoning with some actual data. Now, in the AI world, talk is cheap, right? Everyone claims their system is the best. So to see if this vectorless architecture actually outperforms traditional methods in the real world, researchers built Moffin 2.5. This is a reasoning-based RAG system custom designed for high-stakes financial document analysis, handling stuff like incredibly complex earnings disclosures, and it's powered entirely by the PageIndex framework. They ran this system through the famously rigorous FinanceBench benchmark to see how it handled genuinely difficult financial questions.
Now, what's really interesting about this slide is, just look at the sheer scale of this number, 98.7%. Just let that sink in. That is the state-of-the-art accuracy score Moffin 2.5 achieved on FinanceBench. By allowing the LLM to intelligently navigate the document's tree structure, rather than relying on arbitrary vector similarities, Moffin 2.5 absolutely destroyed traditional vector RAG scores. It proves beyond a shadow of a doubt that when precision actually matters, reasoning beats proximity every single time.
Section 6, deploying your PageIndex. Let's talk about taking action and getting started.
Seeing that kind of jaw-dropping accuracy, let's bring this down to practical, actionable next steps for your own specific environments. You essentially have three main deployment avenues for PageIndex. First up, it's open source. You can self-host and run it locally right now using their GitHub repo, which utilizes standard PDF parsing. Now, if you're dealing with really messy, complex PDFs that need advanced layout recognition, you can use their cloud service via API or the Model Context Protocol, giving you enhanced OCR and much better tree building. And of course, there are enterprise options if you need a full private or on-prem deployment.
To get you up and running instantly, the Vectify AI team has provided several brilliant cookbooks and examples right in their repo. You can try out a minimal Jupyter notebook or spin up an agentic vectorless RAG using the OpenAI Agents SDK. But here is a mind-blowing fact that I absolutely love. They even have a vision-based vectorless RAG pipeline. It doesn't even need optical character recognition. It works directly over the raw page images, reasoning visually about the layout and structure of the document. No OCR required. How cool is that?
It really makes you step back and look at the entire trajectory of AI infrastructure right now. As large language models become increasingly agentic, and as they learn to logically reason over semantic tree structures just like human experts do, will static vector storage eventually become completely obsolete for long professional documents? It's a fascinating question and one that the incredible performance of PageIndex basically forces us to ask. I highly recommend heading over to GitHub to clone the repository and try building a tree index yourself. Thank you so much for joining me on this explainer, and keep building.